How does batch size affect CNN image classification? Imagine trying to teach a robot to recognize pictures. The way you feed it data can change how well it learns and how fast it gets there. That's what batch size is all about. When training a convolutional neural network for image classification, batch size is the number of images processed before updating the model's internal settings. Think of it like a chef tasting a few dishes before adjusting the recipe. Using smaller batches, like 16 or 32 images, often helps the model get better at recognizing new and seen images. This is because small batches introduce more randomness in the training process, which acts like a regularizer. It prevents the model from becoming too fixated on the training data and helps it perform better on new images. For example, in medical image tasks or satellite image analysis, smaller batch sizes tend to give higher accuracy. But keep in mind, the best batch size can depend on the specific dataset and model. Some studies found that a batch size of 90 was ideal for certain remote sensing models, while others suggest starting with 64 or 128 for typical tasks. Larger batch sizes, like 256 or 512, can make training faster because they make better use of powerful graphics processing units. These units can process many images at once, reducing the time it takes to go through each training cycle. But larger batches need more memory space, which might mean using more expensive hardware. If you use very large batches without adjusting other settings, your model might not generalize well, meaning it might not perform as well on new data. Smaller batches also mean less memory is needed, which is helpful if you don't have access to high-end equipment. This makes training possible on more affordable hardware, but it can take longer because fewer images are processed at a time. You might need to train your model over more cycles to reach the same level of accuracy. Batch size also affects how the model learns by interacting with the learning rate, which controls how much the model updates during each step. Larger batches tend to work better with higher learning rates, leading to more stable training. Smaller batches usually need lower learning rates to keep training smooth and avoid instability. In AI applications like medical diagnosis, where accuracy is vital, choosing the right batch size is important. It helps models be both precise and efficient. Smaller batches can improve accuracy and help models learn better, but they take more time. Larger batches speed up training and make good use of hardware, but can sometimes reduce how well the model generalizes if not tuned properly. Picking the right batch size depends on your specific model, the data you're working with, and your hardware setup. It's all about finding that balance to get the best results in image classification with convolutional neural networks.